Hey lighting enthusiasts, this is Steve at Nate Family Lights. What I figure I'd do this today is show the Ammo Box MTM ACR 872 design and kind of do something a little different. There's some videos from last year that I am referencing, and I have a bill of materials list out there. What I figure I'd show you guys today is kind of a take this sucker apart so you can kind of see how it all goes together and show the key design elements that I really liked about this box and the slight modifications to the other designs from last year that were on the other videos. So I have two here. There's a lot of wires here. This has got an F16V3 in it with power injection. So you can see it's the larger box. Just kind of walk around the outside. There's an intake vent. There's four Cat 5 cable connectors there. A bunch of pigtails underneath here. It's got two power in for left side, right side, and then also that network cable is for the in. The four out there you'll see in a minute, it's for the outbound differential receiver boards. This box I used for my Mega Tree. I didn't end up with pigtails for the power injection cable, so I ended up just running these straight out. And you can see I'm using two receiver boards for the Mega Tree, and then for both of these, and you'll see I'll kind of go down here. There's an input on that side. It's got an output here, and you'll see when I open it up the fan. Let me go ahead and open both of these up. Okay, so here's the inside of the unit with the F16V3 right here. Differential expansion board, and I'm using all four. I've got two distro boards here, and what I've done, since I'm using the same pigtails for everything, is I marked in red the ones that are actual just power injection. The rest of them are just data cables that I've got kind of the tape marking here with extra tape wrapped around it. Alright, so that's that one. For the Mega Tree box, you'll see here there's two receiver boards, two power distro boards, the two wires that are coming in for the network. And then, just like the other one, I just laid it out a little differently. Voltmeters here. These are volt and ammeters, but you really only need the voltmeters. And then they're marked here to indicate which power supply it goes to. Alright, so I'm going to switch camera views here so I can take these apart and show you how it looks. Okay, we'll see how well this works. I've got you hanging from the light right above, kind of like a cooking show here. Hopefully the swaying will stop in a second. So what I really like about this is there's two Lexan boards for the mounting plates, one for the top, one for the bottom. The one on the top holds all of the electronics. The one on the bottom mounts all of the power supplies. This box has four 360 watt power supplies, 12 volts, the generic kinds, and these wing nuts here just unscrew. Get these two here. So if you ever needed to do anything with the pigtails, anything on the top, you can address that. Network cabling is all here. I'm using these right angle Cat 5 cables. It's kind of key with this setup. The board on the top gets real close to the lid. So if you have a standard RJ45 connector, you will have some problems with it making those turns. So I'm going to go ahead and disconnect this one, which is the input from the middle, which is coming from the Raspberry Pi or your show player. And these are the four differential receiver outputs. Let me get my finger on the piece there. Actually, let's give this a shot. Yeah, go ahead and unplug all these guys. I've got them labeled on the front, so I could just follow them right into how they plug into the board. Normally you wouldn't necessarily need to do all this. You could literally, if you wanted to, just lift this whole assembly without disconnecting any of these pieces. I'm just doing this now so that way you can see the top board, and I'll take the whole thing out so then you can see better the bottom board. Okay, the fan that I have here is the 4-wire pin fan, which is in the bill of materials. This one goes right to the Falcon board. It actually controls the speed of the fan based upon the temperature inside this unit. The other one that I have is just a standard 2-wire fan, so it doesn't connect any board. It just, when the power comes on, it goes on full speed. It's still pretty quiet, but it goes on full speed. Okay. One, two, three, four. Okay. That being done, this lifts up. Now, it is still connected underneath. So what I did was I ran, if I can move these aside, I ran all of my power underneath. So the plus minus, plus minus, plus minus, plus minus here. I have a pretty thick gauge wire here. This is actually solid core wire that I used from Normal Electrical. I think it's 12 gauge, maybe 10 or 12 gauge. It goes right under the board, and you'll see through the glass here, through the Lexan plastic, I have these Wago lever nuts, which are really nice. If you get the set, you'll have all the different sizes. You can kind of see through here. This one's got a 5 connector, so the very thick red goes in. Anything else that I have tapped off of there, it can be different gauge wires. And when I flip this thing over, it will be very easy for me to then disconnect. So as you can see, here's the main plate. I've got 4 holes cut in for the bolts to run through, and then 2 round holes here for the power supply to vent. If I flip it over, you'll see I put a little piece of the plumbing that's used here for the standoffs right in the middle. They sit right on top of the power supplies. It helps keep the board from flexing when you're pushing down to get your pieces on. And then I used the plumbing for the water line in your refrigerator, that piping, and I just cut little pieces here for the standoffs with the M3 bolts. I think that's a 16mm guy right there with the little lock nut on the front. So that's that piece. But I'll show you a few things that are in here. A few design tweaks. These power supplies are offset, so you'll see the top ones are a little farther back from the bottom ones. That allows me or anyone to get in here, flip up this panel, reach a screwdriver down in there, and loosen things up, tighten things up. I also use these spade connectors, and I used a pretty thick gauge solid wire just to do all the links between the different pieces for the AC power, these 3 on the far right. That way if I need to unscrew and pull them out, the spade connectors just make it a lot easier to slide in, and then the hard wire makes it easier, so if I keep one in the bottom and I take off the top, it comes off nicely. The aluminum pieces here on the side are 1.5 inches. There's a 48-inch stock piece I got, and I cut it into even lengths, so it goes 1, 2, 3, 4, 5, 6, 7, 8. The nice thing there is once you have them, you just drill a few holes in the side. You kind of align them up. And then on the bottom plate, there's screws that you just line them up, drill some holes, and then mount them. All of these power supply mounts are using the M4 screws. What I did was I reconnected all the wires that were going to the Wago nuts. I'm going to flip this back up again. So everything's reconnected back on the back, but what I do want to show is the power here is divided up. Power supply 1, 2, 3, 4 corresponds to 1 is the top left, 2 is the bottom left, 3 is the top right, 4 is the bottom right. So it's kind of mentally separated left and right, and then top and bottom. Power supply 1 powers the left 8 here on the F16. Power supply 3 does the right up here. 2, which does just this distro board, and then 4 does just this distro board. So if any of these voltage meter goes out, I'll know which one is not getting any power, which I should be able to see from the display, and at the same time I'll know exactly which power supply is gone out to be fixed to help with troubleshooting. At the same time, some people use them, some people don't. Underneath here, I can get to flip up enough. There you go. I do have, coming off the power going into each area on the 12-volt side, I do have a auto fuse here with a single fuse, and I have 4 of them. So if it does tend to draw too much current, which I use so much less than the fuse and how much the power supply can handle that, I don't think I get anywhere close to popping this fuse here. But if there's a short somewhere, the idea is that this would go first before you mess anything else up with all these wires here. Alright, so what I want to do is go ahead and show you for the power cords. I only have 2 coming in. The right power cord comes in and it powers both power supplies on the right. The left AC power cord that's coming in powers both of them on the left. And if you can see here, it's kind of hard to see. I'll kind of push some wires aside. This left one, these top 3 are from the power cord coming in. Right underneath it, there's a spade connector. That spade connector goes to these wires, which goes to the bottom power supply. So for me to disconnect the power cable, I just loosen these 3. And because I have these spade terminals, I can pull those 3 out. And now, I'm going to screw these back down because I don't want these jumpers that are going to the bottom power supply to pop out. Now the right side is disconnected from the cable that's going to the cable gland. Do the same thing on the left side. So these top 3 spade connectors go to the power cord that's coming in. And what I did for the spade connectors are these top 3 are facing one direction, so you can see the wires on the top side as I pull them out. The bottom 3, which connects to the lower power supply, are flipped the other way, so they can face back to back to each other without the wires getting in the way. So I'm going to go ahead and tighten these 3 down so they don't come loose. And as you saw earlier, I had already unplugged all the pigtails. So here's the power cord coming in for the left side, the power cord coming in for the right side, goes in there, and then I just have them linked just from power supply to power supply. Okay, so what I'm going to do is put this back on top. And lift it out and show you if you needed to get to a power supply, how difficult that would be, or how easy that would be, depending on your perspective. Okay, so this thing is floating in here. One thing I do want to mention is the size. So this top mounting board is 12 inches by just under, I think it's just under 14. About 14, so 12 by 14. And you'll see that there's a little bit more room here than the other one. This top plate, because I knew I had these pieces with these holes here, I extended it a little farther forward. The bottom plate actually ends right about here, so it's an inch shorter than the top plate. And I'll measure that and show you that in a second. Alright, so now that we have our pigtails disconnected, our network cables disconnected, and our power cords are disconnected, I should be able to lift this whole thing out. Now I do have pigtails that were kind of stuck in there, so let me pull those out. Like that, and this guy, that guy, these network cables. And we are free. So there it is. Here's all the stuff for the mounting plates and the boards. Everything for this is here. Now I'll also point out the space here on this fan. space on the left is okay, but you'll notice the bottom is skinnier than the top. So the bottom plate also is a little skinnier, and I'll measure the bottom plate and show you that in a second. Also, the location of this post is just inside here, so that way you don't run into that screw that's there. So the 4 posts sit there, 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 and there. And what I like about that setup is you're not drilling through the bottom, and you don't have any potential water compromise into your ammo crate. All right, so I'm going to move this aside. Okay, so here is the view of the two kind of together. And let me go ahead and measure the bottom. It's a little shakier here because I'm holding you. Alright, so the bottom one is 11 inches. And I mentioned the top one is a little longer, so the top one is 12 inches. And then across the bottom is 13.5 for that bottom plate. And this one is 14 inches. So when you drill your holes, this one is just a slight bit farther in because the top plate's a little wider and it's a little longer. And you can see this is only so far and this is there. So as far as the placement of these holes, that is at, let me get that a little bit better of an angle, 1.5 inches in, whereas in the bottom it is a 1/2 inch in. In the back, the bottom is at 3/4, and the top is also at 3/4. So the back of this unit is exactly the same. Same thing for the left side. 3/4, 3/4, and then this front is going to be just like the other one. This way. 1.5. Does that look right? I gotta move you to see. Yep. 1.5 there, and then on the bottom is the 1/2 inch as well, because the top overhang is by 1 inch. Not quite in focus. There you go. All right, now onto the other pieces. I know Ricky did a video as well. This bolt that's here is a 6-inch bolt. And these are all, it's a 1/4 inch, 6-inch bolt. There's a nut there with a washer, and then this piece is PVC pipe. Take a look at the bill of materials so you can see what that is. And then there's a washer right there, and on the top was the wing nut. Alright, so one more thing I wanted to show you guys is, should you need to work on the power supplies, you can see everything from here. If you lift the top, you can unscrew everything, but I can illustrate what I have here is the line, the neutral, and the ground. All three are connected together. So that's where when I put power on the top, it does the top and bottom. Same thing on this side. These 3 wires are for the AC. And I just do it on the top. And that one incoming AC line powers the top and bottom. So if you see a problem where this left side or the right side is completely out, then it could just be that your AC line had popped or something like that. And I just have one V plus ground, V plus ground, V plus ground, V plus ground. They're all going to these auto fuses connecting to the Wago nuts underneath. Then they go to the meters and then to the units up top. So I will say drilling these holes here was kind of difficult. I had to drill holes in the corner, a bunch of holes in the middle, and then use an X-Acto knife or some kind of blade to kind of score it, and then break it through with pliers. It was quite a bit of work there. Everything else you could just use standard drill for the hole there, standard holes here, standard drill bits, standard drill bits. You need the hole saw for these guys back here. Okay, and a couple more things to show. The height of this PVC tube is 4 5/8. Let me see if I can get that to focus. So 4 5/8, and all four are the exact same size. Also, what I'm going to do is flip this up so you can see what the bottom looks like. And what's here is you can see the 4 power supplies right through this Lexan plastic, and each power supply, the bottom of each set is got 4 holes to mount them with the M4 screws, and I added a washer there just to kind of give a little space for the screws so that the screws don't go into the too far into the bottom of the power supplies. Alright. And one last thing that I'm noticing here as I'm kind of moving things around is keeping all the grounds connected. So see here, these are the 3 AC lines. This is the ground from the top to the bottom, so that takes care of that. Did the same thing on the right. The other thing that I did was between the left and the right, there's a jumper here for the ground that runs across and then into here. So all 4 power supplies, the grounds are all connected to each other, all from these 1, 2, 3 wires. Everything else is then just standard going over to the electronic boards. You don't have to worry about figuring out how to connect your grounds anywhere else. Okay, let's see. This box is exactly the same. Only difference is I didn't need as much space for the 2 diff receiver boards and the 2 the distro boards. So the top plate and the bottom plate are the exact same size. 11 inches here by 14. The bottom plate's exactly the same. You'll see that there's quite a bit more room here. Got my extra Euro plugs there. I've got a different fan here. It's only got the 2 wire, just the red and the black, and it's just going into one of the Wago nuts under there. So once it gets powered up, it gets going and it just spins. And like the other one, this is also divided. So power supply 1, power supply 2, top and bottom. Power supply 3 and 4, top and bottom. This power supply powers this piece. This one to this piece, this one to this piece, this one to this piece. Probably overkill on the power as far as supply, but I didn't have any issues with the power supplies, even with the Chinese knockoffs. So I plan to be able to use them for many years. As I'm putting it back together, here is what it looks like pre-pushing Pigtails back on. You can see the 2 power cords here. If I pull the right side, the power cord out, we'll see that go down. So the right side on the top is this one, and then on the bottom was this guy. You'll see the left side is still powered. I'll go ahead and unplug that, and we'll see what happens there. So that way it helps to kind of figure out if things are powered or not, what's going on. And there it goes. Cool. Hope this helps.